Only 18% of students got this question right, so let's go through it. The most important part of this question is the fact that it says which statement must always be true. When we see this, our mission is simple. We have to try and find a case where this isn't true. Just start with the easiest example that you can think of. In my case, it's just 6 vertices connected in a loop. First, let's test statement A. We know that a degree is the amount of edges that come off a vertex. Hence, in this case, they're all 2, so they're all even. But if we move just one edge, have a look at this. Now 2 vertices are odd, so option A is not always true. Let's move on to statement B. Remember that a Eulerian trail only uses every edge just once. This happens if there are only 2 or 0 odd vertices. Currently, we have 2, and so this is true. So again, let's try and counter this example to find out where it isn't true. If I move this side up here, I now have 4 odd vertices and no more Eulerian trail. So B is now out of the equation. Now let's look at statement C. Remember, a Hamiltonian path visits every vertex exactly once. If I look at this network that I currently have, it has 3 vertices with a degree of 1. There's no way I can make a path without visiting a vertex twice. So statement C is also now out. Now, to solve for statement D, we can test every graph to try and see if it's wrong, but that would take too long to try and disprove it. Instead, we can actually find a rule to explain why it's 2. The sum of the degrees of all vertices always equals twice the number of edges, in this case 12. This makes sense, because if I take an edge away from one vertex and I add it to a different one, we're just moving the edge. We're not adding or subtracting any of the edges, keeping the total constant. So there's only one answer, and that is D. There's only one statement that must be true. So when you see always true, don't just accept it. Try to break it. If it survives every counterexample, it's probably a rule and probably always true.